Hello and welcome to Science Conversations, a series examining the intersection of science and faith. I'm Dr. Barry Harker and my guest today is Dr. John Ashton. This is my 10th conversation with Dr. Ashton, based upon his book, Evolution Impossible, 12 Reasons Why Evolution Cannot Explain the Origin of Life on Earth. Last time we noted that erosion rates, sedimentation rates and some other evidences conflict with radiometric age dates. We also looked briefly at the problems with radiometric dating. Today, Dr. Ashton will address briefly the accuracy of carbon-14 dating before outlining problems with the Big Bang model. Dr. Ashton is a chemist with a PhD in epistemology, a branch of philosophy dealing with the nature of knowledge and truth. Welcome again, John.
Hi Barry, good to be here.
I'm looking forward to this conversation today. We're tidying off the issue of radiometric dating and then going on to the Big Bang. John, we've discovered that radiometric dating does not work for rocks of a known age. Let's turn now to carbon-14 dating. Could you explain how carbon-14 dating works and what it's used for?
Well, carbon-14 dating has a much shorter half-life system than the other rocks dating methods, such as potassium argon and so forth. These other dating systems have half-lives in the order of tens to hundreds of millions of years and even more. Whereas the carbon-14 system has a half-life of only 5,730 years or thereabouts. And so it's used to date much younger samples, such as historical samples of anything that contains carbon. So that includes plant material, clothing, bones, wood, these sort of things. And it can also be used for limestone and shells because they contain calcium carbonate, and so things like corals, these things can be dated with carbon-14 dating. So it's generally used to analyse samples that are known to be very recent. So in a historical sense.
Does it work for things that are of a known age, like we would expect it to if it was accurate?
Yes, it seems to. There's reasonably good correlation for historical samples back, the past 1,000 years or so. A lot of early work was done with carbon-14 dating before they had the most accurate methods of measuring carbon-14, which involves the atomic mass spectrometry. And so really the most reliable results are post the 1980s. So that's fairly significant, where we've had much more accurate mass spectrometers and we can much more accurate methods of analysis of the actual samples. So in recent times, yes, we've been dating samples and we get reasonably close correlation as far as I understand.
Okay. Now you cite evidence that some fossils that are dated at millions of years contain carbon-14. You also write that samples from supposed different geological periods give a similar carbon-14 age. This indicates that these fossil samples are much younger than the ages assigned to them, doesn't it?
Well, this is a really, really fascinating discovery with regard to the radiometric dating. So a number of studies have been done now where people have taken rocks or samples that have been dated according to the fossil ages as millions of years, and yet when they're dated by the carbon-14 method, then they come back as only, say, 40 or 50,000 years old. So this is really interesting, and particularly studies that have come out just in the past 5 years or so, where they have actually dated dinosaur material. So we've actually removed carbon from the preserved extracts of the dinosaur bones. So remember we talked about the soft tissues. Now these soft tissues contain carbon. And the fascinating thing is that when they analyse these tissues and carbon-14 date them, they get ages again that are only in the tens of thousands of years. So a classic example was a large marine lizard that was the remains removed from an island up near the North Pole, and the conventional dating of that fossil was 70 million years. But yet when the sample was carbon-14 dated, the results came back at only 25,000 years. And so this was by researchers at the University of Lund in Sweden. Now, since that report came out, a group of scientists from Europe, from several universities, took samples of dinosaur remains from different parts of the world and that contained soft tissue, and they found measurable amounts of carbon-14 in all these soft tissues. Now, and again, they gave dates around, the 25, 30, 40,000 years, and yet these dinosaur fossils were typically all older than 70 million years, some up to 130 million years. So, and that paper was published, was presented at a major geological conference. From memory, it was in Malaysia a couple of years ago. So, and the interesting thing was that these specimens were from around the world, from different parts of the world, different locations, and they all consistently gave carbon-14 ages in this range, and not in the millions of years range. Now, the other fascinating thing is that a fellow that contributed to my book In 6 Days, Why 50 Scientists Choose to Believe in Creation, Dr. Paul Guillaume, he's actually an emergency medicine physician and teaches emergency medicine at Loma Linda University. And he was also very interested in carbon-14 dating. It was sort of a research hobby of his to research the papers and reports. And he did quite an extensive study of 70 carbon-14 dating results that were published since 1984. So that's using the modern techniques. He published the study about 2001 from memory. Now, these were samples that were all in the published scientific literature, looking at samples or specimens that were 100,000 years up to millions of years old. And they typically gave carbon-14 ages of only 40 to 50,000 years. Now, there were over 70 measurements that he reviewed, 70 research papers, I should say, that he reviewed. So it's quite a large number from a number of universities, a number of different studies. And what he commented was that it's interesting that these samples were all assigned different ages according to their position in the geological column, but yet they all came back with approximately the same carbon-14 age of 40 to 50,000 years. Now, again, this would exactly fit our biblical flood scenario, that in actual fact all these rocks were laid down at the same time, and it also fits very well the observation that when we look at these multiple layers, such as in the Grand Canyon, they're all sitting on top of one another as if they were laid down more or less in succession, very close together, because there's no signs of erosion.
Yes.
So we've got this fascinating correlation there. I've seen other results where wood has been preserved, say, in a lava flow. Now, we can actually date the lava flow with radiometric dating. And the dating for the lava flow has been millions of years, and yet the dating for the wood has been, say, 30,000 years by the carbon-14 dating. So we've got a major problem with the interpretation of carbon-14 dating, of radiometric dating. But why I think the carbon-14 dating is far more accurate is that we understand more clearly the basis of how this works and the assumptions that are involved. In other words, the initial concentrations of the carbon-14. We have very accurate measurements of its half-life. And the bottom line is that on the basis of the current levels of carbon-14 in the atmosphere, we know that after 100,000 years, there would be no detectable carbon-14 left. So what it means is when we say the half-life is 5,500 years, it means that if we take the level of carbon-14 that there is in the atmosphere at the moment, after 5,730 years, there'll only be half the amount left in a specimen. And perhaps I should back up a little bit and explain how carbon-14 works as well. So in the atmosphere, there is carbon-14. Now, carbon-14 is formed by the action of cosmic rays striking the upper atmosphere, and these cosmic rays are high-energy, positively charged particles that are hitting the upper atmosphere, and when they strike atoms in the upper atmosphere, they then emit high-energy neutrons. Some of these high-energy neutrons then strike nitrogen atoms in the upper atmosphere. And what happens is they knock out a proton from the nucleus of that atom. Now, the type of element that an atom is defined by the number of protons in the nucleus. So carbon has 6 protons in the nucleus, nitrogen has 7 protons in the nucleus. So if one of these high-energy neutrons knocks out a proton from the nucleus of the nitrogen atom, that atom now becomes a carbon atom. But nitrogen has a mass of 14, so it now becomes a carbon atom with a mass of 14 instead of carbon-12, which is the more common form. Now, this is your carbon-14, which is now radioactive, and it slowly decays. That neutron that's there, or one of the neutrons there, slowly breaks down back to a proton and emits a beta particle or electron. Now, what it says is that after 5,730 years, half of those radioactive atoms will have decayed back to carbon, back to nitrogen. And so that's the principle of carbon-14 dating. Now, when that carbon, radioactive carbon, gets into the atmosphere as carbon dioxide, it's taken up by the plants, and animals eat the plants, and so it gets into the animal chain as well. And so essentially plants, living plants and living animals are in equilibrium with the carbon-14 in the atmosphere. So they have the same ratio of carbon-14 in their tissue. We have that same amount in our bodies and in our clothing. But once something dies, it's no longer exchanging these nutrients, and so the amount of carbon-14 there stays fixed, and it then just decays away. So if we found something with half the current level of carbon-14 in it, and we measure that very accurately with a mass spectrometer, then we would say it was 5,730 years old. If we found that there was only a quarter of the level, then we would say it was 11,460 years old. So that's how it works. So the smaller the amount that remains, the older the sample. Now, what it also means is that after 16, 17 cycles, because the initial concentration of carbon-14 is so low, the amount of carbon-14 remaining will virtually be down to 1 or 2 atoms, which will not be detectable by our very accurate mass spectrometers. It will be below their detection limit. So it's the fact that we actually find measurable amounts of carbon-14, we find plenty of it there, enough to calculate these ages, means that in absolute terms, these samples must be less than 100,000 years old. So what we have with the carbon-14 dating is a very accurate absolute measurement of a limit to age, at least. So it means that these samples must be less than 100,000 years old. And yet, according to the other radiometric dating methods and the fossil dating record, which again was based on sedimentary rates estimates, they give millions of years, and that's, as we can see, they're all based on unproven assumptions, and, the data there is very, very fuzzy. We saw before that there is a lot of inconsistency. You can get hundreds of millions of years difference in ages for the same rocks just using different methods with radiometric dating, whereas the carbon-14 dating is a lot more consistent, and we can see there is an absolute upper limit for it. So in my mind, this provides very, very powerful samples that these very, very powerful evidence that these samples and these specimens of the dinosaurs and so forth are much, much younger than claimed to be according to the geological column.
So the coal and the diamonds that have measurable carbon-14 content then would have an upper age of 100,000 years. But there's also some evidence to suggest that those dates can be revised downwards. There's something in your book to suggest that there was a higher carbon content in the biosphere in the past. What's the significance of that?
Okay, well, yes, let's have a look at that. Because the coal is believed to be, the black coal, at least 30 million years plus, up to, say, 300 million years, and diamonds are believed to be billions of years old, typically 2.5 to 3 billion years old or 3,000 million years old. Those samples were generally not carbon-14 data because they knew, well, they shouldn't detect any carbon-14 there. But just over 15 years ago, several studies were done of the coal samples that are actually preserved at Penn State University. These are the coal reference samples that have been taken from mines across the United States where they've taken very large slabs of coal, stored them under argon, and and they're preserved there for research purposes. Now, they took about a dozen, or samples from a dozen different of these coal specimens and analysed them for carbon-14. And again, they got ages around the 40 or 50,000 years for these coal samples that were over 30 million years old. Now, the same amazing results were obtained for diamonds. They took diamonds from freshly out of De Beers mines. They took alluvial diamonds. And diamonds are very hard elements. They're not likely to be contaminated. Again, when they were analysed, they gave ages in the order of 50, 60,000 years by carbon-14 dating. So we've got massive differences. Now, one of the things about the coal is we find around the world massive coal deposits. And this suggests that the carbon dioxide content in the past in the atmosphere was much higher. Now, just in the newspaper, and I think it was on the news too, just 2 weeks ago, a leading Australian scientist working in climate change was pointing out that the increase in carbon dioxide in the atmosphere that we're producing due to the increased burning of fossil fuels now in the world, if this continues on for another, at the same rate, for another 5 years or so, by 2020, if we went to date a T-shirt that somebody is wearing today, it would come out with the age of about the same time as William the Conqueror, 1,000 years ago. Why? Because this increased carbon dioxide is actually diluting the levels of carbon-14 in the atmosphere. And the lower the age in the atmosphere gives you an artificially older age.
Mm-hmm.
So what this scientist was saying, that we could date a T-shirt that we know, came from cotton, that was, harvested a year ago, so maybe, a couple of years ago. So it would give a zero age, and yet we would find now, compared to the standards that we're using for carbon-14 levels, the level now would be lower because of the lower level of carbon-14 in the atmosphere, which we would then calculate as being 1,000 years old, when in actual fact we know it's, a year old, Now, this is quite fascinating. So, again, the fact that we know that these levels were much higher in the past, these older ages, in actual fact, would have to be corrected further and brought down younger. The other fascinating thing is, too, that we're often quite happy to go out into the bush here and date some indigenous campsite or remains and this sort of thing in a cave, or in a cave in Europe, and say, well, it's 40,000 years old and this sort of thing. But yet we get really upset when people find the same ages or even younger in the carbon from dinosaurs. So really we know that these ages all have to be brought forward. There's actually more too. The carbon, the cosmic ray flux hitting the Earth is determined by the Earth's magnetic field. So the Earth's magnetic field has protected us from cosmic rays in the past. And we know that the Earth's magnetic field is declining now. It's declined about 6% since 1900. So again, if that was much stronger in the past, that would have repelled more cosmic rays, which means, again, there would have been less carbon-14 formed in the atmosphere, which again gives us, on the basis of our interpretation today, an artificially older age. So when we take these factors in, and again, we can't know accurately, and this is the important thing, we can't know for sure on the basis of any dating method that we do today, absolute ages, unless there was a historical witness. But what we do know from these methods, that they provide limits for the maximum ages. And when we allow for some of these corrections and make estimates, it pulls these radiocarbon ages that we're getting of, 25, 30, 40,000 years back to 4,000 or 5,000 years ago, which brings us right into alignment with the biblical date for the flood. So in my view, this is very, very powerful evidence. When we combine this with the fact we're finding soft tissues in dinosaur, we're finding blood remains, bits of DNA, all these long-chain polymers which would normally break down over time, especially over millions of years. We have the parallel layers of the sediments with very little signs of erosion in between. We have the examples of fossils of trees growing up through what would otherwise be thousands of years of layers. When we combine this with our carbon-14 dating from so many samples around the world that are giving these consistent ages, and the important point that even though according to the geological column they're supposedly millions of years apart, yet they all give the same carbon-14 age approximately, it all points back to the picture that the Bible paints of the global flood and in recent years. And
there's certainly not enough time to have evolution take place, is there? Even with these upper limits.
Exactly.
So these are serious anomalies that you've described over the last couple of sessions.
They're very, very serious problems for evolution. What we see from the data that we can measure here and now, there definitely isn't enough time for evolution. The evidence of evolution in the fossil record is not there, like the gradual change of animals. We don't see the gradual development of insects. We don't see the gradual development of turtles, or we don't see the gradual developments of so-called dinosaurs changing into birds. there'd have to be a lot of steps. The amount of genetic information that has to be changed to change the code from a dinosaur into the code of the bird, and for all the feathers and those enormous. There'd have to be absolutely trillions of mutations producing all little bits of new information according to evolutionary theory. It's just not there. It's just totally missing. And as I mentioned in the past, we've had top paleontologists like Barbara Stahl at Harvard and David Rope, who was president of the US Paleontological Society for many years. And in recent times, and as if these were, back in the olden days, in the 1800s or anything, this is in modern times, with modern data saying, yes, the evidence isn't there of evolution in the fossil record. When we put this all together, we've got a very, very, very strong picture that supports the biblical account.
So let me just tidy off this whole session on radiometric dating. We've discovered a huge disparity between erosion and sedimentation rates, their calculations, and radiometric dating calculations. You also write that, combined with DNA mutation rates, the discovery of soft tissue and dinosaur remains, and historical evidence for a global flood, that this all points to a massive extinction event just a few thousand years ago, consistent with what the Bible talks about.
Exactly.
Okay, let's turn now to the Big Bang Theory. This is one of those theories that I'm sure everyone wants to understand but finds it difficult to understand. In reading your account, I found it very clear. But tell us what the Big Bang Theory attempts to explain.
Yes, the Big Bang Theory persists in our textbooks and in our school classrooms as an explanation of how the universe came to be, because really scientists don't have any other explanation that comes close to explaining how we can be here other than the biblical account. And so they cling to the Big Bang Theory despite the growing evidence that it just doesn't work. They do these calculations and predict something. They go out have a look through the telescopes to try to observe it, and very rarely do they find the evidence. Matter of fact, I think I read a statement in one of the science journals, or one of the papers critical of the Big Bang Theory, that not a single prediction of the Big Bang Theory had been verified by experimental observational
So that's why
evidence.
they're having to have all these fudge factors involved in the theory.
Yes, well, the latest one I understand is dark photons. So we've got dark energy, dark matter, and now we've got dark photons. And
so these are having to be brought into the theory to help explain the observations, aren't they?
Yes, they're very dark because nobody knows what they are, and no one's seen them, and they've never been measured.
So tell us about the Big Bang.
It's a bit of a joke, really.
Tell us about the Big Bang and the supposed process by which it took place. I understand that the theory predicts or assumes that from the Big Bang, from the singularity that exploded, that we have all the elements that make up the universe. Tell us about it.
Yes, that's right. There's the common, perhaps, Big Bang scenario is a hot Big Bang theory where you have a singularity. So a singularity just refers to a one-off event where you had, for some reason, a massive amount of energy expanded, and and the space as well expanded in a fourth dimension, and this energy coalesced into hydrogen atoms, and then those hydrogen atoms coalesced into formed helium, and then and higher elements under the influence of gravity were synthesised, fused, and you had fusion reactions occurring to produce the elements, and these elements condensed into the stars and eventually planets.
So it's a completely naturalistic theory. It assumes that there was no divine intervention. It doesn't purport to explain where the singularity came from.
No.
As I understand it, but there was nothing, essentially, but then something formed. How did that form? I mean,
Yes,
this is a problem, isn't it?
Well, there's different. I guess there's a couple of issues there. So when we look at that's the real Big Bang. Well, that's the Big Bang theory as it's described. In many people's minds, though, the Big Bang theory is a little bit different. It's subtly different, and I'll explain this. Many people think that there was this energy explosion, and this intense burst of energy expanded in space and converted into matter, and then that matter condensed into the stars and planets. But that's not the Big Bang theory that is described actually in the textbooks, but that's how many people understand. Now, many listeners probably didn't pick up the difference. The difference is in the latter version, you have energy expanding in space. In the true Big Bang theory, you have space expanding in a fourth dimension. And there's a subtle reason for that, and it's purely a choice, it's purely a hypothesis, but it's a purely hypothesis to make it appear that we are not in a special position in the universe. Whereas when we look out into the universe, we seem to be in a very special position to act near the centre of the universe and in the position to observe the whole universe. And so really, in many ways, it's almost as if the scientists have contrived the construction of the Big Bang theory to take out the obvious evidence that we seem to be in a very special position here and point to the existence of God. And perhaps I can backtrack a little bit. What is this singularity? Well, we don't know. It's a one-off event, but we can describe the sort of thing that sometimes physicists play with. Now, some people may remember when they did physics at school that you could have a wave tank, and so this is a tank of water in which we can generate waves, much like you see waves when you go to the beach. They're the water moving up and down. Now, it's possible to generate a wave, so we've got the water moving up and down and travelling along this tank from one side to the other by having a little rod moving up and down at that end of the tank. It's also possible to generate a wave from the other end of the tank so that it comes along, and if you get the frequency or the rate of the cycles the same, then those and you have more or less an identical system, the same end, so they have the same amplitude or height of the waves. It's possible to send waves from opposite directions, and when they meet, if they're out of phase by exactly 180 degrees, the peak of one wave will correspond exactly to the trough of the other. So as the two waves pass over one another, the water actually will go flat, because they've cancelled each other out. Now, imagine this experiment was going and they set the two waves off, and just as the waves were passing and was flat, you walked into the classroom. And so when you walked into the classroom, you would see a flat pond, and then suddenly a wave forms out of that pond, as if it's come from nowhere. So my understanding is that with this singularity, they don't know what happened before time. But then suddenly, for some reason, this energy expanded. So that's the sort of scenario that physicists can sort of play around with to explain how you can appear to have nothing and then something appear. So, I mean, it's obviously not water in a tank, but I'm just trying to illustrate there how you can have the appearance of nothing and then something come from it. But it really isn't nothing. What it is it's just the way things had balanced out at that particular time. Now, the other concept is this expansion in a fourth dimension, and the reason why they have that construct in the Big Bang theory is, imagine this. Imagine that you are blowing up a balloon, and with this balloon you've actually, on the surface of the balloon, you've painted little circles. So say it's a typical party balloon that might blow to, say, 300 millimetres in diameter, 30 centimetres in diameter, a foot across. And when it's small, so just a few inches across, you drew little circles on it, maybe a quarter of an inch or 5 millimetres in diameter. You drew a whole lot of little circles on this. As you blew it up, those circles will expand, but they'll also move apart, away from one another. And so what happens is the surface of that balloon is 2 dimensions, but the balloon is expanding in 3 dimensions. So that way you have it apart. Now, the other thing is, when you've tied off the balloon, where's the centre of the balloon? That spherical surface has no centre, ignoring the part where we blew it up, but it has no centre. That surface, because it's a surface, has no centre. So mathematically you can do the same thing with the universe. So that's why they have the universe supposedly expanding in a 4th dimension, because that way the universe would have no centre. And that way it would explain why the universe all around us appears to look the same, because they say, well, we're just looking over a surface. But the point is, there's no evidence for that 4th dimension. We haven't detected a 4th dimension. It's just a mathematical construct to meet that particular requirement of the Earth not being in the centre of the universe, where if you look at it logically and you go out there, we're in the centre of the universe.
So if it's a non-observable event, that simply means that it's not science. It's somehow it's transitioned out of science.
It's a hypothetical construct, yes.
But if it can't be tested, it's not technically science, is it?
Well, so far we haven't detected a 4th dimension.
I'm Dr. Barry Harker, and you're listening to Science Conversations. My guest is Dr. John Ashton, author of Evolution Impossible, 12 Reasons Why Evolution Cannot Explain the Origin of Life on Earth. John has been examining how carbon-14 dating gives much younger ages to fossils, coal and diamonds than standard geologic column ages assigned to them. He's also been discussing some significant problems with the Big Bang Theory. We'll go to a break now. When we come back, John will talk about what we actually observe and the implications of this for the Big Bang Theory.
If you have any questions or comments in relation to today's program, you can call 3ABN Australia Radio within Australia on 02 4973 3456, or from outside of Australia on country code 612 4973 3456. Our email address is radio@3abnaustralia.org.au. That is radio@3 Australia, all one word, .org.au. Our postal address is 3ABN Australia Inc., PO Box 752, Morisset, New South Wales 2264 Australia. Thank you for your prayers and financial support.
If you've just joined us, I'm Dr. Barry Harker, and you're listening to Science Conversations. My guest is Dr. John Ashton, author of Evolution Impossible, 12 Reasons Why Evolution Cannot Explain the Origin of Life on Earth. John has examined how carbon-14 dating gives much younger ages to fossils, coal and diamonds than the standard geologic column ages assigned to them. He's also been discussing some significant problems with the Big Bang Theory. For the remainder of this conversation, John will focus on the problems with the Big Bang Theory. John, what are some of the contrived assumptions that support the Big Bang Theory?
Well, when we have this expansion of energy and then matter in the Big Bang, in order to get the distribution of matter and so forth as we see in the universe, it must have expanded much more quickly than we would observe under the current laws of gravity and physics as we know them. So in order to meet the requirements of the Big Bang Theory and get the uniformitarian, the uniformity of matter that we see across the universe, then they have to invoke what is called inflation energy field, an inflation energy field. And that is that essentially there was some energy field that accelerated the universe much faster than we can explain by normal physics. Now, this really gets to me in some way in that, I've had people say, well, we can't teach, creation and that God created the universe in science classes because, we can't test that theory. We can't do an experiment. And yet they're happy to invoke and teach the Big Bang Theory and invoke inflation theory. Again, you can't prove that. You can't test that in any way. You can't measure it today. It's just a hypothetical construct that they've had to include in the Big Bang Theory, otherwise it doesn't work. And there's other ones. There's dark energy as well. There's dark matter. It's called dark because we haven't been able to detect dark matter yet. And there's, several reasons for this. See, for example, we often hear, the first elements formed as gases and they condensed into the stars. But we know that hydrogen gas, helium gas isn't going to condense unless there is other pre-existing matter for it to form on. And so this is a major quandary for the Big Bang Theory. There's another problem as well. When, according to the law of Baron number, if you convert energy into matter, you produce an equal amount of matter and antimatter. Now, to give you an example, we have an electron, that is matter. The antimatter to the electron would be a positron. So when we look out into the universe again, at the present time, it's 95% or so matter. We don't see the antimatter that should have formed. And so there are so many major problems that with the Big Bang Theory, it just doesn't fit what we observe. And so what happens is they just contrive new parameters, hypothetical parameters to try and make it work. But prominent scientists and cosmologists have spoken out about the Big Bang Theory now for more than a decade. You had Halton Arp, who was head of the Max Planck Institute of Astrophysics in Germany. You had Hermann Bondi from the University of Cambridge. You had Thomas Gold, who was Professor of Astronomy at Cornell University. These were some of the world's leading astronomers that had problems with the Big Bang Theory. Fred Hoyle had problems with the Big Bang Theory. When he described the Big Bang Theory, when he was describing like the physics, he said, "Well, is it a Big Bang sort of thing?" Meaning it in a sense, well, is this some kind of joke sort of thing? So we've got major problems there with the Big Bang Theory, and these leading astronomers have pointed it out. I mean, there was a letter published in the New Scientist some time ago. I forget the exact date. I think it was around 2004. Was published in New Scientist, where a large number of these astronomers signed a letter to New Scientist saying, look, there are major problems with the Big Bang Theory. For example, Dr. Richard Liu at the University of Alabama in Huntsville, they analysed the data from the NASA Wilkinson microwave probe, and they analysed data from 31 galaxy clusters. And they were looking for the evidence of shadows that should have been cast by the foreground galaxies in the cosmic background radiation from the supposed Big Bang. However, not a single shadow associated with any one of the 31 clusters was detected, which is powerful, directly observable evidence that the Big Bang never happened. So, another major problem with the Big Bang is the prediction of the satellite galaxies. Now, Dr. Pavel Krupa, he actually studied here in Australia at the University of Western Australia there, his physics degree there, and then went on to study astronomy at Cambridge University. He's currently the professor of astronomy at the University of Bonn in Germany. And he pointed out fairly recently that we only observe about 1% of the number of galaxies that the Big Bang Theory predicts. In other words, only a fraction, 1% of the galaxies that we should see predicted by the Big Bang, we actually see. And he said this is, in one of his papers, he writes, this is the clearest evidence that there is something badly wrong with the Big Bang model for the origin of galaxies we observe in space. And as I said, at the present time, unless they have this dark matter there, they can't get the gases to condense. It's sort of like if you imagine, if you boil down a sugar solution or a salt solution, some solution in water in a very, very clean beaker, you can concentrate it and concentrate and concentrate it down, but you won't form crystals. They won't form. But the moment you put a little seed crystal in there, shoom, that the whole thing will then suddenly crystallise. It's the same, well, it's not exactly the same actually because they're different forces. We're looking at gravity. But it's the same thing with the problem with these gases. None of these gases are going to have sufficient gravitational attraction to pull them together to then generate the fusion-type conditions to fuse the elements unless there is some sort of matter there to start with. And then how did that matter form? First of all, we haven't seen it, we can't observe it, and how did it form? There's a huge number of unknowns, yet without those, we can't have matter forming. And, so the universities have, published data on this. So, on some of the university websites, they have, they list the major current problems with the Big Bang theory. There's a research professor at the University of Adelaide at the present time, Dr. John Hartnett, and he has a website. It's johnhartnett.org, and on that he lists a lot of summaries of the evidence that we now have that the Big Bang just doesn't work. It just doesn't fit the observed data. But because these aspects are so highly technical, it's very different for most of us to sort of understand the significance of the lack of evidence.
John, what do we actually observe, and do these observations support or deny the Big Bang Theory?
Well, one of the requirements of the Big Bang Theory is the existence of what is called dark matter. Now, this is matter that we can't detect but exerts a very strong gravitational effect. You see, without the existence of dark matter, there would be no way that the galaxies and stars could form. There's no way that they can form from the initial elements that are gases that are formed. No way. So they have to have this dark matter. Now, so far, this dark matter has never been detected, and yet, according to the calculations and predictions of the Big Bang Theory, something like 95 to 98% of all matter should be this dark matter, and yet we haven't detected it.
Is it in principle undetectable? I mean,
well, we do all sorts of experiments to try to detect it, but on the other hand, we have very strong evidence that it doesn't exist. And this evidence is if all this matter was out there in the universe exerting a gravitational effect, then it should be accelerating our galaxies much faster than they are. So our galaxies rotate about 50 kilometres per second. If all that dark matter existed, we can do the calculations. Their galaxies should be spinning at hundreds of kilometres per second. Now, there's more evidence against as well. So, for example, the satellite galaxies of both the Milky Way and the nearby Andromeda galaxy are in a disk configuration. Now, this is just as what would be predicted if the gravitating mass is just ordinary matter. If the gravitating mass were actually dark matter, then the satellites would have to be in a random sphere, not in a disk situation. And this evidence completely contradicts the dark matter hypothesis, as Professor Pavel Kroper at the University of Bonn points out, and many other researchers have pointed out as well. So here we have direct observational evidence of different types that says the dark matter doesn't exist. We observe behaviour of the planets and the stars in the universe as if there was only just normal gravitational matter that we observe. They only require this dark matter to make the Big Bang Theory work. But there's more. There's other things that the Big Bang Theory requires, and that is it requires inflation theory to overcome a whole lot of problems. Now, inflation theory essentially says, or inflation says that right at the beginning, gravity was repulsive and pushed things apart for a very short period of time. Well, I mean, this is totally contrived. There's no, evidence whatsoever for that, except that we need to make the Big Bang Theory work. Now, the other aspect of the Big Bang Theory is that you've got this expanding universe. But, of course, the latest data is showing that, in fact, the universe isn't expanding. For example, if this expansion was really occurring, we would produce time dilation phenomena resulting in two light curve broadening effects for supernovae. However, it's now been discovered from the study of the widths of supernovae light curves that there's only a single broadening effect observed. So these observations again provide direct evidence that the Big Bang didn't happen. And again, the observed surface brightness measurements of the galaxies is consistent with the evidence that the Big Bang didn't happen, that we have instead a relatively steady state universe. So these are all data that we can actually measure right at the moment. The surface brightness of objects per unit area in the sky, measured as photons per second, is a constant with increasing distance for similar objects at those distance. The Big Bang, on the other hand, predicting an expanding universe, predicts that surface brightness, as defined above, would mean that the more distant objects actually would appear bigger. These observations show that and they've got many observations of surface brightness because, we've been doing this for a long time now. And what we find is that when we measure the surface brightness, the measurements show us that they exactly concur with a non-expanding universe. And this is in a sharp contradiction to the Big Bang. And again, they've invoked all sorts of, explanations to try and refute this. So, we have major problems with the Big Bang Theory. And another one is just for the Big Bang to produce even the first elementary particles. We have to have what are called the grand unified theories or GUTS. And what these are saying is that what they're proposing is, in order to make the Big Bang Theory work, they have to propose that initially in this very hot state there was no difference between the strong and weak nuclear forces and electromagnetic forces. But we have no evidence for that. They've just got to assume that, otherwise it doesn't work. But if they do assume that they're all together at that time, then when they spin out the mathematics and do their predictions, then what happens is they predict that very massive particles should be formed called magnetic monopoles, and these should be heaps of these distributed out throughout the universe. But again, these have never been detected. So the bottom line is this. The Big Bang Theory makes, as this attempt to explain how our universe came here, but just about everywhere we look, the evidence for it has failed. Another example would be the prediction of the formation of the lighter elements. So that's deuterium, helium and lithium. From the Big Bang calculations, we can predict that in the early stars, for example, that we see like way in the distance, the level of lithium should be quite high. But from the density measurements and these sort of things that we can measure now, we find that the predictions for deuterium, lithium-7 and helium-4 are in contradiction not only with the predictions but also with the predictions relative to each other. And so some scientists have now gone as far as to say the chance that the Big Bang Theory is actually correct, just on the basis of the major problems with predicting lithium abundance in the universe, the chance of the theory of being correct is less than 1 in 100 trillion. So you've got very poor chances just on the basis of what it predicts for the abundance of lithium. So, as I said, there are other major problems. When we look out in space, right, we've got these the galaxies and the way they're layered. That means that the matter has had to come together. Now, when we do the basic calculations, it would require hundreds of billions of years for the galaxies to align and to separate themselves and come together the way they are. But in actual fact, of course, the calculations of the Big Bang Theory, it's about, I think they fine-tune it down to about 13.8, billion years. But hang on, we observed all this matter has sorted itself. Another one is the horizon problem that we've got. So energy is constrained. The speed at which energy can travel is constrained by the speed of light. That's the maximum rate at which energy can travel. So the Big Bang Theory is sort of a random process, because that's one of the things that underpin the whole concept of the Big Bang Theory. It has to be random, and otherwise you're invoking an intelligent designer sort of thing and design. But if it was random and this matter is forming randomly, according to the dark matter theory, then how come we've got all this energy is so equally distributed around the universe? There isn't enough time if energy travels at the speed of light, for it to redistribute itself. So that's the horizon problem, and so that's why they have to invoke dark energy and again this massive inflation to try and solve all these problems using hypothetical constructs, because when we look at the predictions of the Big Bang and when we look out there, what we actually observe in just about every area, it contradicts what the theory predicts. And that's why, as I mentioned earlier, there are literally hundreds of scientists who have made public the fact that they oppose the Big Bang and that it's ridiculous to continue with this theory because there's so much evidence against the theory actually being a viable explanation for our universe. But when we look at creation, it fits the data perfectly. It's amazing how well the creation model fits what we observe out there.
I'm Dr. Barry Harker, and you've been listening to Science Conversations. My guest is Dr. John Ashton, author of Evolution Impossible, 12 Reasons Why Evolution Cannot Explain the Origin of Life on Earth. John has described how carbon-14 dating gives much younger ages to fossils, coal and diamonds than standard geologic column ages assigned to them. He's also outlined some significant problems with the Big Bang Theory. Next week, our conversation will be concerned with some highly qualified scientists who reject Darwin's theory of evolution. Don't miss it. Bye for now, and God bless you.